I'll do some review of stuff. Oh, here, before I forget, let me give you guys the practice test. Oh, one more. That's Finishing 7, getting into 8. Chapter.
And our test will be next
Tuesday, 19th.
All right. Jesus Christ! All right, so I love you guys. This doesn't always happen, but very often the practice test is a little longer than the actual test. In this case, maybe a little bit. Yeah. All right. So for right now, glance at that and then put it away. So on Monday, I'll have the answer key for that. Monday, we'll finish up chapter 8, and then the rest of the time will be devoted to review for the test. Again, summer. Hello. So let's do an example of what we did last time. And then I probably would let us take a little break early because I want to run back to my office. I was helping somebody out with word problems yesterday. And there's a word problem handout I gave out a few semesters ago to my 90 students. I can give it to you guys as a review for word problems. I've gotten very few questions about the word problems, and normally that means that people saw it and went, I'll just skip that shit. Which is not a good way to be. Not a good way to be. Let's do one. All right, let's do one like we did what we did yesterday. That's crap. Yeah, okay.
section is this from?
7-6.
All right.
Oh, crap. All right, here's a bad marker. Need a good marker? Yeah. Man. It's
Got a
refillable
4 or
ones.
1.
You can't get high off of these. The other ones here. So this one is actually kind of starts off a lot easier than the ones we did yesterday. Some people might overthink this problem, but what's the only fraction you got in it? Yeah, and it's an equation, so I'm allowed to kill the fraction. So what do I do? This is the one place, if there's only one fraction, I'm not going to do the whole make the bottoms the same. I'm just going to go ahead and multiply that by that thing. Multiply by what? There's no real reason to do it the whole way. There's not a lot of stuff to keep track of. So I'm not going to do it that, make all the bottoms the same first. There's no real reason for it. So you get y squared plus 4 equals negative 5y. And now it's really just, you remember what to do here. Yeah, add 5y, I like it. Put it in the right place. Now why did we do that?
One question. How did you get 3 Y's when there's only 2? Like, I get like you would take a Y and you would freaking multiply everything, but why did you, how did you keep it like 3 Y's?
Are you ready? I'm not sure what you mean by 3 Y's.
So
So you're cool with multiplying by y, right?
yeah.
Okay. So we multiply both sides by y. That's going to distribute, so I just say put a y next to everybody.
Okay.
So then this is the y squared, that's the 4, and that's the negative 5y.
So if there's a Z, you can just take a Z out and add a Z as long as you can get the solution, the answer.
You're doing that to get all the bottoms the same.
I'm doing that to kill the only bottom there is.
Okay.
When there's more shit happening on the bottom, then I make all the bottoms the same, so it's easier to keep track of stuff. Is there a lot to keep track of here? No. So this is one place I just say multiply by that thing. I like it. How are we doing? And then why did we add 5y? Why did I want to make it equal to 0?
Let me figure out why.
Because there's a y with the higher power than 1 on it, right? I don't care what the shit's going on. I'm trying to figure out what y is. Why did I do this specifically? Because that's there. If that wasn't there, I wouldn't have done that. If that wasn't there, I would have just divided by -5, right? So telling me that I'm trying to solve for y doesn't tell me why I added 5y. I'm adding it because of that stupid dude right there, right? And now I do what? Factor. So y is -4 or -1. Cool. Does either one of those make it undefined? The only thing that would make it undefined is if y was 0, and I didn't get that. So both of those are valid. All right. Yes.
If one of those was 0 and one of them wasn't, how
Then you just cancel the 0 and circle the other dude.
Oh,
I like it. That's all. Just whatever doesn't work, you cross through it. If the two things and neither of them work, you cross through both and say no solution. Yeah. If they both work, awesome. You circle both. All right. So watch this. Now here's. Let me show you. I'm gonna do this problem longer than we'll need to show you why the shortcut works. This is a shortcut that already came up. Somebody tried to use it in the wrong place. I've got. What do you got, Joe? Yeah, I like it. Now watch. Now remember what I just said. If you don't want to write down what I'm about to write down, you don't have to, because I'm going to do it a long-ass way. I'm going to do it this way. I'm going to do it the way we normally would. Not even this way, but the way we did yesterday. What do I mean by that? Well, what's this guy missing that he's got? X. Just go with me. I know somebody out there is like, again, damn, this guy. You just do this. What's he doing? I'm showing you why that works. He's missing an X. Oh, yeah, you don't work. He's missing an X. And, of course, he's missing an X plus 1. Right? And then what would you do? You made the bottoms the same, so I'm going to... Once I get all the bottoms the same, why? Because now I'm going to multiply everything by that bottom. So they'll all cancel. Why are there fractions? Because things have bottoms. I'm going to kill them then. All right, so if I multiply both sides by x plus 1, I get 3x equals 5 times x plus 1. Now basically, no matter what this thing started off as, if I have one fraction equals one fraction, the same thing is going to happen. This is going to look like it just came up here. That's going to look like it just came up here. So cross multiplication is a shortcut to the process we would use anyway. If there's one fraction equals one fraction, I can cross multiply. It's just a shortcut. That's all it is. And now that's, J, right? So this will be 3x equals 5x equals 5. Subtract 5x. Negative 2x equals 5. Divide by 2. Negative 2 bit. So from here down, better be easy. Is that all right?
So when you cross multiply, you're just gonna always bring them up.
Yes. So another example. And the biggest mistake I see, real quick, the biggest mistake I see is I'll have this problem, the same problem we just had, and somebody will write this, and they'll circle that. Now on the surface, you should be able to identify a huge problem. It was an equation, and now it isn't. right? You can't like get rid of the equal sign. Divide by the equal sign. No, it's impossible. So that should be a big problem, right? And why do we bring them up? Because that's what it looks like when I apply the actual process. It's just a shortcut. So if you just look at a shortcut, it doesn't make any sense by itself. It doesn't. Right? You got to look at where the shortcut came from to make it make sense. Yes?
So essentially, you just pull, it's like for example,
Yeah,
3, you
this
just
is
pull,
wrong.
you just pull the x's of
That goes up there.
And
That goes up there and multiplies. And that's why it's called cross.
And the equal sign.
Multiplication.
How would you go from there to x equals minus 5 over minus 2?
Well, when you bring that up, what do you get?
3. Yeah.
When you bring that up, you get,
Oh, okay. I see.
which is that. Keep going.
I forgot to keep it and separate them because of the equal sign.
Okay. All right. So you'll see a few of those running through that section 7.6. Yeah, I like it. Yeah, let me show you
Oh,
this.
yeah, this question.
Let me show you this. Here is where cross multiplication screws you over, right? Because it's just a shortcut. Shortcuts sometimes shouldn't be used. If I did this shortcut, I would bring that up and bring that up. I'd have 4x squared minus 32. I have to distribute the 4, distribute the 7, get all my x squares and stuff together. Oh my God, holy shit. If I do it the actual way, what would I do first?
Factor.
Factor. I'm just going to do that very quickly. And then you see, what's he missing that he's got?
4.
No,
Minus 5.
he's got an x minus 3, so what's he missing? Just the x minus 5. And what's he missing? X plus 3. Did I need any? No. And then you would multiply both sides by this LCD, so it would cancel, right? Is that? And see how you have a much nicer equation than you would have gotten if you just blindly did cross multiplication.
So it's just like make sure that it's factored before you try to do the cross multiplication.
Yes, if you factor the bottoms and there's something they both have, you should do it the full way,
Okay.
because it actually makes it better than the shortcut in that case.
And then from there, you solve for x.
Yeah, now you just solve for x. Yeah.
That's cool.
You have a much nicer equation now. Do you see if I would have just brought all this shit up here, I would have had 4x squared minus 32x plus 60. Oh my God, you got to distribute the 4, right? I would have had 7 times x squared minus 9. I would have had to pull everything over, equal to 0, factor. Holy shit. And then one of your answers would have been not true and so forth. It would just sucks. This kicks ass, right? So that's why in general I dislike showing too many shortcuts. Because number one, you lose sight of why it works. You forget the concept. And number two, sometimes a shortcut makes shit harder. Okay. And this, so you subtract 4x, subtract 21, divide by 3, 41 over 3. Yummy, yummy. All right, that from there to there, you guys should all be able to do. So that's why I do that fast. Okay. How's that? Is that decent? You guys see that? Okay. So some of you guys try to use cross multiplication everywhere, and I'm telling you, you shouldn't even use it in the one place that it can be used sometimes. So you're going to need to turn that around. All right, now, let's see if I want to get into this a little bit. Yeah, I'll get into this a little bit, and then I'll give us a break, because I want to go back and print out that word problem sheet, because section 7.7 is word problems involving rational expressions. Yay! Two of my favoriteest things. So let me do this first example because it's kind of like its own little standalone process, and it's called a work problem. I can't remember what the book calls it. I don't care. What this means is, see if this sounds familiar at all. Sam mows a lawn in 2 hours, some certain lawn somewhere. Some big ass lawn. Joe mows it in 3 hours, because Joe is either slow or very meticulous. I don't know. How long would it take them both to mow that lawn if they work together? Now, to me, one of the most funny answers is 5 hours. And I'm like, okay, that doesn't make any sense. 2 plus 3 is 5, Jeff. But, all right, are you saying that they would take some time out to fight? So we're assuming that they don't, like, detract from each other's normal time. They just each do their own, and then when their lawnmowers touch, they're like, oh, we're done. So obviously the answer has to be less than what?
3.
Definitely, but even better, it's got to be less than 2. This dude can do it in 2 hours working well. If he had some help, it better take less than 2 hours. You guys with me? Okay. So here's how this works. Sam can mow 1 lawn in 2 hours. So this is kind of like in 1 hour he'd have half the lawn mowed. Does that make sense? In 1 hour he'd have half the lawn mowed. Joe can mow 1 lawn in 3 hours. So in 1 hour he'd have a third of the lawn mowed. So if I add those together, that should be the total amount of the lawn they have mowed after an hour. So this is going to represent the time it takes for them to work together to mow the lawn. This is almost too nice to believe. I can do it in 2 hours, he can do it in 3 hours. Together, we can do 1 lawn in how many hours? Right? So it's its own standalone. It's not even anywhere near a normal word problem where you got Joe drives 20 miles an hour faster than Sam. That's a whole other beast. This is beautiful. Right? How do I solve this? Yeah, comment on. So the number is going to be 6, right? And of course, everybody's going to need a T. So this guy needs what to become 6? 3, and he needs a T. This guy needs 2 and a T. And this guy needs 6. Right? I mean, once you set up the equation, you solve it like you always would. Setting up the equation is normally in a word problem the hardest step, of course, right? So I get 3t over 6t plus 2t over 6t. There you go, 6 over 6t. So then I can multiply by 6t. Is that cool? Just like we always did before, right? Just like in 7-6. So then I get 5t equals 6. I get t equals 6/5. And to put it in terms that a human would say it in, closer at least, 1 1/5 hours. That's better than 6/5 of an hour. It's like, how long does it take you to get home? Well, 8/3 of an hour. What the hell are you?
It's almost 1 hour and 10 minutes.
1 1/5 hours. How can I make that even better? What's 1/5 of an hour? How long is an hour in minutes?
60.
What's 1/5 of 60? 5 goes into 60. 5 goes into 60. 5 feet is how many? 12. Right? So this is 1 hour and 12 minutes. 1 hour and 1/5 of an hour. So it's 1 hour and 12 minutes. It's better. It's the ultimate way to say it as a human. Every time I say something like that. All right, so that's not too bad. But let's. So that's not bad. Those kind of problems you should just eat them up. Let me go. That's always creepy when I do that. I'm gonna go print out that word problem worksheet. Let's take like a 15-minute break. Come back at like 9:30. Are you everybody okay? Are you okay? Okay. Come back at 9:30.